Just a quick reminder, if you have any questions at all, don't hesitate to post on Piazza. The odds are, if you have a question or you're confused about something, there's probably a few other people that are also confused. So please post on Piazza with any questions you've got. So in the next few videos, we're going to look at dictionaries. So this models a searchable collection of entries, which are key element pairs, and so all of the operations that we have are key-based. So when you insert an item, you specify for this object, this is the key associated with that object. And then anytime we want to access that object, we access it based on its key. So we find an element based on this key, or we remove an element based on this key. And as with anything, we can always check to see how many items are in this container. Are there no items in this container? And we could also get a list of all of the keys or all of the elements. Now there's a variety of applications here, like using this in order to keep track of an address book, which would store, based on last name, that would be the key, some pertinent information like someone's phone number and address. A standard word dictionary also follows this setup, so definitions are searchable based on the word. And then this is also useful for domain name server to map host name. So what you would type in your URL as a URL in your browser, mapping that to an actual IP address for the server. Now there's two kinds of dictionaries. We have, let me put this here, we have ordered dictionaries and unordered dictionaries. Now the only difference between these is based on whether or not the keys that we are given are ordered, or at least whether we care about any ordering to those keys. So both of them support the standard functions to find, insert, or remove an item based on a key. Both ordered and unordered dictionaries do this. But with an ordered dictionary, there are some additional operations supported, like, let's see, find closest key, maybe before the closest key before some particular key, or the closest element whose key comes before some other key, or find everything in the range of, so maybe find everything within the range of a kind of a lower bound of a key and an upper bound or a right bound of a key. So an ordered dictionary will support some other key-based operations, which assumes that there is some order to keys, whereas an unordered dictionary is useful for either if our keys have no order defined on them, so these operations can't be implemented, or maybe they do have an order to them, but we don't care about what the order of keys is, or at least we maintain no guarantee that our data structure will maintain any sort of order to keys. So what we're going to focus on for this series is unordered dictionaries. And when we move to binary search trees and other kinds of search trees, that will be an ordered dictionary implementation. So for an unordered dictionary, how would we implement these functions? Just find, insert, or remove an item based on its key. So one kind of straightforward way that we could implement this is just with an unsorted sequence. So this is called a log file. So this is an implementation of a dictionary just by using an unsorted sequence. So when we insert an item, because we don't maintain any kind of order to the sequence, and we can't maintain any kind of order because our keys might not have an order defined on them, we just add it to either the beginning or the end of our unsorted sequence. So we just keep adding it to the end, and we can do that in constant time. So if we use an unsorted sequence to implement a dictionary, insert item is constant time, whereas our other operations to either find an element or remove an element based on its key would be linear time, and this is because we would have to scan through the entire sequence in order to find where is the item that is associated with this key. So in the worst case, we'd go through the whole thing and there are n elements in there. So this would really only be effective if we have a really small dictionary, not a lot of elements in it, or if perhaps inserting an item is the main operation that we perform and we don't really find items or remove items. So This could be like a historical record where we just keep adding, here's the next thing which we did, and we don't often go back to find old records or to remove a record. But we'll see how we can improve the running time of these operations using instead a hash table in order to implement these unordered dictionary operations to insert an item based on its key and specify what its key is, and then find or remove an item based on its key.